Hello everyone, welcome back to the new video of this GIS software video series. Today we're gonna see different type of interpolation. On previous video we saw one interpolation system which is IDW. Today we're gonna see different types of interpolation and the comparison between them. So let's jump on our new project. So this is our new project which shows that this is a map of Bangladesh. If you go to if you take this Thana, we're going to see different type Thana in Bangladesh. And if you click on the union, we're going to see the union headquarter all over the Bangladesh. So if you go to the union headquarter attribute table, we can see that different types of parameter. So our new project is we have a new Excel file. If you go to this, you can see that there are different name Union Parishad name of Bangladesh and their manganese level. Uh, if you see that this manganese level is included only for this Union Parishad, and if you want to take this data to our this shapefile, we have to join the data in this shapefile. So if you go to this Union Parishad and go to join and relate, and if you click the join, we select the UP name which is similar to our Excel data's title, and if you from here, if you go to the Excel file and select the database and hit add, and if you also add UP name, if you hit OK, yeah, it is done. We have joined all the data, Excel data in here. If you open the attribute table, we can see that there is a new name which says the UP name. We have two UP name, but these values are shown at null. So if you go to the data and double click, you can see that there is a Union Parishad name and their manganese level. But if you scroll down, there are all null values because only 100 and something Union Parishad are here. But if you go to the attribute table, we can see that there are more than 4,000 data are here. So if we go to scroll down, we can see the all null values, but we don't need the null values here. So how we can delete them? To do that, we go to this Union Parishad properties and go to definition query and go to query builder and select database manganese, which is not equal to 0, and hit OK, apply OK. Now only the selected Union Parishad are selected. Now we have to export this data for further saving. So you go to the Union HQ and go to data and export data. We'll save here the output here. It saves and OK. So yes, and you can see the exported data. We don't need it anymore. Now we will work on this exported data, but now we have to run the all interpolation system in this data. But if you check check the interpolation system, we have to make this data into two sets. We will which will help us to check the interpolation system for further knowing. Now we'll go to the customize and go to toolbars. We will add a new toolbar which is called geostatical analysis, and from this we'll go to the geostatical analysis drop down and hit subset feature. Here we can divide the data into two parts. So input the data which is export output, and we will output the feature training feature class and we'll save it to here, training, save, and the other feature class we will name it test. Yeah, and the size of the feature class, sorry, say test, and the percentage of this training feature class will be 80% will take, and hit OK. So the test and training data is selected. We'll cross this, and now we'll change it color for further visualization. OK, and also change it color and decrease its size. So we can see that our data is divided into two. We will work on this training data and we will verify the data with this test data. So we will not need this. Now we will run different types of interpolation system on this data. But first we have to set the environment to make this properly. We go to the geoprocessing and go to environment. Here we'll go to the processing unit, and extent will be the same as the layer. And if you go to the raster analysis, we'll give the cell size as specified below. We'll include the cell size which is 50, and the mask will be a which is our Bangladesh shape file. We hit OK. So the environment has been set. So now we'll run the interpolations. If you go to the search and search the IDW, we go here and hit the IDW. Now we'll put the input point feature, which is the training data, and the Z value will be the manganese, and we'll save it. IDW if save, and we hit OK. Now the IDW is running. It will take some time to complete. Now we untick this, and we can see the interpolation, IDW interpolation has been done successfully. So we will run the other interpolation system. We'll go to search and go here, and if you will run the Kriging this time. In this here also we'll input the training feature. We'll go to the Z value and manganese, and also we'll save it as name Kriging dot tif. Save it. Now the other parameters will be default, and we hit OK. Now the Kriging is running. It will also take some time to complete. Now the Kriging has been done successfully. Now we'll go to the again another interpolation method. We go to search, and here we'll now select the nearest neighbor and input the value. It's training, again manganese, and we'll save it. We hit save and we hit OK. Now the nearest neighbor interpolation is running. Now the nearest neighborhood interpolation has been done. Now we'll go to search again, and from here we'll now select the spline. We'll input the feature which is training, and again Z value, and save it. Now we'll hit OK. Now the spline interpolation system is running. Now the spline interpolation video is completed successfully, as we can see. Now the 4 interpolation system we have done it. The IDW, Kriging, natural labor, and the spline. We have got different outcomes. Now we will put this outcome to the test data to verify if our if the interpolation system is right or wrong. So to do that, we will search name which is extract multi extract multi-file is to point. We click it and we'll input the test data, and the raster will be these four of it. We'll hit add again, the IDW. Yeah, the four system, and we hit OK. The multi-values are extracted into points. We have to untick this for. If you go to the test attribute table, we can see that the spline, natural neighbor, Kriging, and IDW's value are extracted to points according to Manganese level. And if you see that there are variation in spline and IDW and different interpolation system, if we take this data to Excel and we can um, we can take the RMS value for see for next analysis. If you can see which interpolation system is better for this manganese value, so that's how we can do it. And if we cross this and see our four different interpolation system here in spline, the number the lowest value are in negative. Also in Kriging the negative value are shown, but it is impossible for negative value of manganese in certain areas. In this case, we can take the natural neighbor or IDW. In this case, I am taking the IDW for further analysis. Now we'll see the contour, different contour in this map. To show contour, we will search the contour. Go to contour. We'll select this and input the raster, which is we'll select the IDW and save the output feature. Then contour dot tiff, save, and the contour interval. From this IDW analysis, we will give the contour interval 0.2 and type will contour and we'll hit OK. Now, as you can see, the contour are made on this map. To good visualization, go to contour properties and go to symbology and go to categories, and here we'll select the control and untick this and add all value. Now we'll OK. Now different types of contour coloring has been shown. So that's how you can show a contour on a map for different raster. Now we'll see the zonal density of different zones according to the district in this map to show in which districts the manganese level is high or low. How we can do that? We have to first dissolve this Bangladesh map into the district. So by this Thana at feature class, we can do that. So we go to the geoprocessing and go to dissolve, and we will input the Thana and we save it. List, save, and dissolve field will be the district name, and we hit OK. So the dissolve is complete. We can see we use the contour. Now we will verify, we will zone different type of contour level in this district to see which district is more manganese, has the more manganese in their area. We'll go to search and we'll search zonal density. Sorry, we'll search the zonal, and here we can see the zonal statistic. We'll click on this, and here we'll input the raster, which is our district, and the field will be the district name, and the input raster will be the IDW, because we are doing the IDW, and the output raster will save it zone.if. We'll save it, and we'll select the mean statistic type. Here different statistic type can be selected. We'll select the mean. Now we'll hit OK. Now it is running. So the zonal statistics is running. So it has been completed, but it can be shown. So we go to the zone, this new feature class properties, and go to the symbology and hit classify. Here we'll select a color. We'll hit OK. We'll close the list, and here we can see the different districts based on their value. Here the low values are in green and the red values are in more level of manganese. So that's how we can see that the red marked districts has a higher percentage of manganese in their area, while the green one has the lower value of manganese in their district. So that's how we can uh, zone a defined area according to the manganese level. So that's all for today. Thank you everyone. See you on next video.